With 4.5 billion passenger trips taken each year and more than 16 million planes taking off annually in the US alone, commercial airlines provide affordable travel on a global scale. But the aviation industry has a big issue: emissions. Aircraft are responsible for 2.5% of global CO2 emissions, and the problem is growing.
Hi, and welcome to the Technology Advancement Research. Today, we are going to talk about a comparative study for the business model and the research and development at NASA, at Boeing, at Airbus, with the US Air Force, Canadian Air Force, Canadian Bombardier, aircraft manufacturers, and Lockheed Martin.
Great design is timeless, but the future always beckons, opening new doors to new possibilities, empowering us to imagine new solutions to the world's most complex challenges.
And we're going to talk about the renewable energy, their approach and their business model, and the research being conducted in these institutions and the companies.
It's estimated that about 650 million people watched the first moon landing in 1969, nearly a quarter of the world's population. As the world watched those powerful Saturn V rocket engines burst into life, they witnessed plumes of sooty exhaust billow from the 5 shuddering nozzles as it pushed itself off the ground, burning through a colossal volume of kerosene to lift the rocket's massive 3 million kilogram weight off the ground.
So, starting with NASA's renewable energy testing centers, electric aircraft prototypes, and research facilities, NASA's dedication to renewable energy is evident in projects like the X-57 Maxwell, which aims to revolutionize electric propulsion. The agency conducts extensive research on renewable energy systems, including solar panels with increased efficiency energy storage solutions, and the integration of hydrogen fuel cells in aerospace applications by utilizing advanced.
It's estimated that about 650 million people watched the first moon landing in 1969, nearly a quarter of the world's population. As the world watched those powerful Saturn V rocket engines burst into life, they witnessed plumes of sooty exhaust billow from the 5 shuddering nozzles as it pushed itself off the ground, burning through a colossal volume of kerosene to lift the rocket's massive 3 million kilogram weight off the ground.
Simulations and computational modeling. NASA reduces the time and cost associated with traditional testing, accelerating the adoption of green technologies. On the business front, NASA's strategy hangs on collaboration, partnerships with startups, universities, and established companies have turned NASA into an innovation hub. Through its Space Act agreements, NASA licenses its technologies to private firms, ensuring sustainable revenue streams while sharing research findings to stimulate industry-wide growth.
Ensuring that a forward operating base maintains reliable power is one of the most dangerous parts of military ground operations. Convoys and supply lines are a major target for adversaries. Ground-based solar, while seemingly an attractive solution, is limited by area, the size of collectors required, and climate.
And now let's talk more about the US Air Force pioneering renewable integration and strategic partnerships. The US Air Force views renewable energy as a critical component of operational resilience. Research focuses on integrating renewable power sources such as solar and wind.
Soon, the first stage shut off and separated, allowing the second stage to roar into life, this time powered by a different fuel, liquid hydrogen, a fuel capable of providing better performance, but it occupied too much space. Liquid hydrogen is considerably less dense than kerosene, so needs to be combined in a much higher ratio with liquid oxygen. For every litre of oxygen burned in the Saturn V first stage, it required 0.64 litres of kerosene, while its second stage needed 3.25 litres of hydrogen for every litre of oxygen.
But if the solar panels were in orbit, they could have unfettered access to the sun's rays, providing an uninterrupted supply of energy. AFRL's Space Solar Power Incremental Demonstrations and Research, or SPIDER project, strives to develop a design concept that will collect solar energy using highly efficient photovoltaic cells.
With advanced energy storage to create hybrid microgrids for the bases. Their renewable energy program is experimenting with liquid biofuels and exploring the use of wind tunnels to test aerodynamics with energy-efficient designs.
Solar energy will be converted into radio energy and beamed to a receiving station on Earth. It will then be converted back into power for use by the warfighter and other end users.
The Air Force business strategy revolves around focusing partnership with the private sector leaders like Lockheed Martin and Boeing.
Arachne, SPIDER's flagship experiment, is a small-scale vehicle which will demonstrate and validate 3 of the 5 critical technology elements that will need to be matured before a full-scale prototype can be built.
By sharing the financial burden of research and development, the Air Force reduces costs and accelerates innovation.
Energy collection, RF beaming, and beam shaping and focusing, or metrology, will be developed and tested with Arachne. 2 other critical technologies, stowable and deployable structures for space vehicles, and thermal management of solar power collection in space, are also being pursued in parallel to the Arachne effort. These small-scale proof-of-principle prototypes lay the foundation for the development of a full-scale operational system. This project paves the way for a system that provides reliable power while eliminating the need for costly and dangerous convoys used to refuel generators in remote areas. Much like the
Moreover, its contracts with sustainable aviation fuels create a ripple effect, driving demand across the commercial sector.
global positioning system, this solar beaming system could transition from military to common use, providing solar energy regardless of weather, time of day, or latitude. AFRL, fast-tracking the science fiction of the past into the reality of the future.
So now let's move on to our next segment, which is regarding DARPA, Defense Advanced Research Projects Agency.
Soon, the first stage shut off and separated, allowing the second stage to roar into life, this time powered by a different fuel, liquid hydrogen, a fuel capable of providing better performance, but it occupied too much space. Liquid hydrogen is considerably less dense than kerosene, so needs to be combined in a much higher ratio with liquid oxygen. For every litre of oxygen burned in the Saturn V first stage, it required 0.64 litres of kerosene, while its second stage
U.S. Defense, Disruptive Renewable Energy Research and Funding Models. DARPA thrives on disruptive innovation. Recent research includes the development of bioengineered LDI for jet fuel and energy harvesting materials that convert mechanical distress into electrical energy. DARPA also finds AI-driven simulations to model renewable energy and systems for extreme environments, optimizing designs before prototyping. DARPA's business model is unconventional. It operates on small, high-risk, high-reward contracts, often outsourcing projects to startups and academic institutions. By offering milestone based funding, DARPA minimizes risk while enabling the rapid development of groundbreaking breaking technologies. These innovations often trickle into the commercial sector, influencing energy and aerospace.
Stage needed 3.25 litres of hydrogen for every litre of oxygen. NASA engineers couldn't feasibly make the Saturn V first stage fuel tanks any larger, so liquid hydrogen was not an option. The science of rocket fuel is a fascinating and complicated field, combining not just physics, chemistry, and engineering, but
Space industries globally. Now, so let's move on to the next, which is the Boeing. Boeing renewable energy in commercial aviation. Boeing's focus on renewable energy revolves around sustainable aviation fuel (SAF) and lightweight materials.
In the long term, the biggest challenge facing the industry is emissions.
The airlines are constantly asking the manufacturers, we want to burn less fuel. It's not just about being green, it's millions of dollars difference in the fuel savings that they have.
The company's Eco Demonstrator program tests renewable technologies from advanced wing designs to electric taxiing systems, reducing fuel consumption by up to 20%. Boeing is also investing in renewable energy powered manufacturing plants, ensuring sustainability across its supply chain. Boeing's business model emphasizes global partnerships, collaborations with SAF producers, government incentives, and co development initiatives with airlines like United have positioned Boeing as a leader in green aviation. Their focus on scalability and long-term sustainability ensures a competitive edge while adhering to environmental regulations. And it's also important to talk about Lockheed Martin.
In the future, Lockheed Martin engineers immerse themselves in revolutionary design systems, turning ideas into solutions at speeds we can't even imagine today.
So, for Lockheed Martin, defense meets renewable innovation, hybrid propulsion systems, renewable powered UAVs, and Lockheed Martin's R&D labs. Lockheed Martin integrates renewable energy research into its defense projects.
Our scientists design groundbreaking materials and define a whole new art of the possible for the solutions we deliver.
Innovations include solar powered drones, hybrid electric propulsion systems for helicopters, and energy dense batteries for long term endurance missions. Simulations conducted at their Skunk Works facility optimizes these systems for both performance and environmental impact. Lockheed's business model leverages diversification. By integrating renewable energy into its defense offerings, Lockheed reduces dependency on fossil fuels, appealing to governments prioritizing sustainability. Additionally, their focus on multi-domain operations, land, sea, air, and space broadens market opportunities, securing contracts in both military and civil sectors. Now, we will also talk about Canada. For Canadian Air Force and the Bombardier, their renewable innovation in aviation. The Canadian Air Force leads in renewable energy adoption through the development of off grid renewable power systems for Arctic operations. Advanced simulations test the reliability of hybrid grids in extreme climates, paving the way for energy self sufficiency.
In deep space, the sun always shines. Solar panels in the proper orbit absorb 10 times the amount of energy than those on the ground, and they do it 24/7. In space, where weight is no problem, gossamer thin structures can grow like enormous flower petals, many kilometers on a side. Sunlight gathered by the huge array is converted to a microwave or laser beam, then transmitted to special ground stations on Earth.
Bombardier, on the other hand, focuses on eco-friendly designs for business and regional jets. Their latest Global 7500 jet incorporates lighter composite material and SAF compatibility. Bombardier's E2 program is researching electric propulsion for smaller aircraft with extensive testing in aerodynamics efficiency. Bombardier's business model centers on customization and niche markets by catering to high-end clients and regional airlines. They maintain profitability while investing heavily in green technologies.
Said, the times they are a-changin'. It will soon be much cheaper to reach space and build things up there. It's still an expensive dream, but the payback from the energy solar power satellites provide will be enormous. Our need to keep ourselves warm, cool, move from place to place, while keeping our electronic gadgets topped up, is straining our energy systems to the limit. And that demand for power is expected to triple by 2100. And even more serious, carbon emissions from fossil fuels are warming the atmosphere of the planet. We need a clean energy alternative to avoid further climate change. There is some effort to reduce our fossil fuel use. Gas tanks are being replaced with electric plugs. But all those batteries in electric cars need to be charged, which will place even further demand on the electric grid.
To meet evolving regulations. And now we are going to talk a little bit about Airbus. Airbus, a green revolution in aviation.
Fuels. This is why hydrogen already gets used as a fuel in space launch.
The promise of a zero-emission plane that could compete with jet-fueled aircraft has everyone from big players like Airbus to new startups exploring the technology.
There's been some successful flights, in fact, but it's all been...
Airbus is the forefront of renewable energy integration with projects like the Zero E initiative, which aims to produce hydrogen-powered aircraft by 20...
on small regional aircraft.
And with the aviation market expected to grow, this new technology could represent a big opportunity.
We have today $1.5 trillion market that we are transforming and we need to transform. The growth rates are some of the highest of all transportation types.
All the technology is here today. Now is the perfect time to use hydrogen to overcome this issue of climate change.
1985. Research focuses on cryogenic hydrogen storage, high-efficiency fuel cells, and AI-driven flight simulations to optimize designs for emission-free flights. Airbus's business model emphasizes collaboration across the supply chain, partnerships with energy providers such as Shell and Total Energies, ensure the availability of green hydrogen. Meanwhile, Airbus invests in digital twin technology to simulate aircraft performance, reducing development costs and timelines. Their commitment to sustainability extends to their manufacturing processes, while it increasingly rely on renewable energy sources.
Liquid, you're storing at minus something like 425 degrees Fahrenheit.
There are a lot of durability challenges with fuel cells. What happens when the aircraft tilts and rolls? The fuel cell has to stay humidified, and that can be a challenge.
So let's conclude now renewable energy and business synergy. Across the aerospace and defense industries, renewable energy is not just an option, it's a necessity. From NASA's collaborative research to Airbus' hydrogen ambitions, each institution demonstrates unique approach to integrating sustainability into their designs and business models. Together, these innovations are not only redefining the future of aviation, but also contributing to a cleaner, more resilient planet. As we look to the skies, we see a future where innovation and sustainability soar hand in hand.
The Juno mission is the most far out use of solar cells to power a space mission to the outer planets.
So in our next few videos, we're going to talk more about various other technologies as business models and research and development. So you can always subscribe and share the video, and you will get more videos like this. Thank you.